Everyone, hope you are doing well. I'm Reza, the founder of the optimizationct.com. In this presentation, we are going to learn how to formulate a dual model in linear programming with the simple model. Let's get started. In this presentation, we will introduce the linear programming model for this problem. And then in the next section, we will explain how to construct the dual model based on original formulation. Now let's define the linear programming model we are working with. This model consists of two variables, x1 and x2, and we have two constraints. So let's write the dual model. To formulate the dual model, we follow the following approach. Since the original model is a maximization problem, so the dual model will be a minimization. First, y1, the dual variable for the first constraint, and y2 is the dual variable for the second constraint. We have the minimization, and the objective function is 2 right-hand side of the first constraint times y1 plus right-hand side the second constraint times y2. The first constraint in the dual model. The coefficient of x1 in the first constraint, which is 1, become the coefficient of the y1 in the first constraint of the dual model. So we have y1. And the coefficient of the x1 in the second constraint of the original model become the coefficient of the y2 in the first constraint of the dual model. So we have 5 y2. And the coefficient of the x1 in the objective function of the original model become the right-hand side of the first constraint of the dual model. So we have 5. Since x1 is non-positive, this constraint is written as less than or equal to. The second constraint to the dual model. The coefficient of the x2 in the first constraint of the original model become the coefficient of the y1 in the second constraint of the dual model. So we have minus 6 y1, and the coefficient of x2 in the second constraint of the original model become the coefficient of the y1 plus 7. y2 in the second constraint of the dual model. And the coefficient of the x2 in the objective function of the original model from the right-hand side. So we have 2. Since x2 is non-negative, this constraint is written as greater than or equal to. Additionally, we must analyze the characteristics of this constraint for the original model. The first constraint in the original model is greater than or equal, meaning its dual must be non-positive. So we have y1 is non-positive. And the second constraint original model is written as an equality. So y2 is free in sign, meaning it can be positive or negative. By following these rules, we successfully formulate the dual model of the original. In this example, we saw that if a constraint in the original model is greater than or equal to, its dual variable is non-negative. If a constraint in the original model is less than or equal to, its dual variable is non-positive. And if a constraint is written as an equality, its dual variable is unrestricted in sign. Now, here is an important question to consider. What is the relationship between the feasible and infeasible solution of the original model and the dual model? This is a very important question that we will answer in the next video. Please share your answer in comments. Thank you so much for watching us. If you have any question or need assistance, feel free to contact us via email or through our website contact form. Do not forget to subscribe our YouTube channel to stay updated with new videos. Goodbye.